Hi everyone, I'm Avdesh God. In this video, we will learn about the type, logical, and date built-in functions in Tableau. Well, let's get started. What if we do not want the decimal places of a field to be included in a calculation, or in a view? We can easily take care of this. Using the type conversion functions. We have multiple type conversion functions over here, out of which integer is one of them. For our scenario, we can easily take care of the scenario that we have discussed using an integer function, which is represented by the abbreviation int. The integer function takes up a single argument. The return type of the integer function is, as expected, an integer. Let us create a quick calculated field using the sum of profits. This will truncate the profits to the closest integer in the direction of 0. That is, the value 4.25 will become 4 in this case. Let us name this accordingly and hit OK to save the same. Let us create a quick view to bring the actual profits and the integer of profits to the view. We will drop the subcategories over to the row shelf, set the view to entire view, and thereafter we will drop the profits over to the column shelf along with the calculated field that we have just now created, that is, integers of profits. To understand the working of integer function, let us turn on the labels and format the fields to occupy 2 decimal places. Over here, we can clearly see that in case of accessories, the value of sum of profits has been converted into integers by removing the decimal portion. In the similar fashion, float functions works as well. This function takes up a single argument which should be numeric in nature and returns a floating value for the same. Let us create a quick calculation for the same in the column shelf itself. This time we will use the quantity field. We'll hit OK and the calculation will be available in the view. Let us format this to 2 decimal places as well. Now what if we want to convert a numerical value into a string and showcase it as a dimension in the view? Let us create a quick calculator for the same. But before that, let us clear this view. As we cannot concatenate a numeric value to a string value, that's why we have converted the sum of profits into string first, and thereafter we have concatenated it to subcategories along with 2 spaces and the opening and closing parentheses. We have utilized the plus operator to concatenate these strings into a single one. But notice, our calculation is still not valid. Can you guess what exactly are we missing out here? Well, reason being, we are mixing up the aggregate and non-aggregate values. The sum of profit tries to come up as a single record if nothing is specified in the view. But suppose we have specified the subcategories onto the row shelf. So in that case, the sum of profits will try to come up at the subcategory level, that is, an aggregated form. But over here, the subcategory field is not aggregated at all. To get rid of this error, all we need to do is enclose the subcategory field in either a max or a minimum function. Let us do it. Our calculation is valid now. We have used the max or a minimum function because of the reason that the same subcategory will remain the same if we bring it at a subcategory level. That is, as long as we are going to use this calculation at a subcategory level, the use of minimum or maximum in this calculation along with the subcategory field will work fine. Let us save this as subcategory profits field. We'll hit OK and save this. Let us quickly bring the actual subcategory and this new field that we have created right now onto the view. If in case the list of fields grows quite long, then we can use the search functionality out here in the data pane. Let us quickly search for the field that we have created just now. Thereafter, we can bring the same to the view. If we notice, we are getting a huge number after the decimals over here in the view. We can easily get rid of this. To remove the decimal places, we can enclose the sum of profits into the integer function first and then into the string function. Let us quickly edit this field and make the changes. Our calculation is valid again. As soon as we hit apply, the changes are visible in the view. And that's how we can have both the strings and numeric values in the same field. Let us now discuss some other type conversion functions as well. To do so, let's create a calculated field. We'll change the type from all to type conversion. We have an option of makeDate over here. The makeDate function expects 3 arguments. All of the 3 arguments are integer in nature. The very first argument is the year, the second one is month, whereas the third one is day. Combining these together, the makeDate will form a date. Let us quickly form a date using this function. Let us use the year as 2021, the month as March, that is 03, and over here I have specified an invalid date. Let us see how Tableau deals with it, although the calculation is specified to be a valid one. Let us name it as makeDate. We'll bring the same to the view onto the row shelf. As we can see, the years are specified as null. Even if we drill down, we have got an expected error. This is due to the same reason as we have specified an invalid day. Let us edit this and make this date as a valid one. Once we do that, the view changes accordingly. And over here, we can see the year, quarter, the month, and the day as well. As we'll make changes to the makeDate calculation, the view will change accordingly. This makeDate function is quite useful if we want some reference date. Suppose the logic for calculating the profits has changed from the month of March. So in that case, we can create a reference date using makeDate and use it in further calculations to specify different logic based on a reference date. In the similar fashion, the makeDateTime function works as well. But over here, we need to specify only 2 arguments, that is the date and the time. Whereas in case of makeTime function, we need to specify 3 arguments. One is hour, second is minute, and the third one is second. and this will return the output as time. Let us move to the logical operators now. We have got many logical operators over here. We can see the same once we change the dropdown to logical. We have case statements, if-else statements. Thereafter, we can even see the and or logical operators. Let us try to create a similar logical expression for profits or losses which we created in the very starting. But this time, let us try out with a case statement. Remember, the case statement does not accept a logical relation. So in this case, we will create a logical expression to figure out the order IDs which has neither profits nor loss. The case statements takes up an expression and then all the values with its results followed by a when statement. And at the end, we can also specify a else statement if no when statement is being met. Finally, it ends up with an end expression. Let's close this and hit OK. Let us quickly clear the view and bring order IDs onto the view. We will use this case output onto the filters to filter the order IDs which had neither the profits nor losses. We'll hit OK to filter the results. And over here, we can clearly see the order IDs which had neither profits nor losses. Thereafter, we have several other functions. That is, if null. If null takes up two expressions. The very first one is a field, whereas the second one is a value that we want to return if the value of the field is null. We have a isDate function as well. It takes up only a single argument that is string in nature and tests whether this string is a date or not. If this string is a valid date, then the isDate function returns a Boolean expression that is true, otherwise false. Let us quickly move to the aggregate operations. We have been using some of these aggregate operations from quite a while now, such as sum, average, maximum, minimum, etc. We will discuss the level of detail aggregate operations, that is, fixed, include, and exclude, at the end of this section. The other operations that we have over here, such as count distinct or count, or even the variation and variation p, can be utilized in the similar fashion as that of sum, maximum, minimum, etc. Finally, we have the date functions. We will start off by using the dateAdd function. The dateAdd function takes up three arguments. The very first one is the date part that we want to add to the date that we are passing to this function. It can be year, month, day, or even an hour, minute, or second. Thereafter, we specify the second argument, which is the interval. If we have specified a year over here, then the second argument specifies how many years we want to add to our date. If we have specified months in the first argument, then the second argument specifies how many months we want to add to the date that is eventually specified as the third argument. Let us save this and hit OK. Let us bring the order date to the view as well. Let us also bring the new calculated field that we have just now created. Over here, we can clearly see that 1 year is being added to the calculated field that we have created based on the actual order date. This is what we intended for. Thereafter, we have a date different function as well. Let us create the same using the calculated field. The dateDiff function will take up three arguments. The last two arguments are the dates based on which we want to find the difference. The first argument is the date part, that is the format in which we want this difference to be seen. We have chosen it to be months. As we already know, the difference between the actual order date and order date plus 1 year will be 12 months. Let us see how it comes in the view. Notice, as we are having it at a record level, let us wrap it up in the average function. Our calculation is valid. We will hit OK and bring the same to the view. As we can see over here, the dateDiff function represents the difference between the order date and the order date plus 1 year, which is equivalent to 12 months because we want the date difference to be in months. If we want, we can change it to the year as well. Let us quickly do that. As soon as we change the calculated field and hit apply, the same is available or applicable to the view as well. Thereafter, we have quite handy functions that can give us the date or time based on the current date and time. That is, the today function, which does not take any argument, returns the current date. Whereas on the other hand, the now function, which also does not take any of the argument, returns the current date along with the current time. Thereafter, we have a minimum and a maximum function. The minimum function works in two ways. One is a row-based operation, other is a column-based operation. If we pass only a single argument to the minimum function, then it will work based on a column-based operation and return only a single value, that is minimum of the field passed throughout the entire dataset. On the other hand, if we are passing two expressions to this function, it will be acting as a row-based operation, returning the minimum of two expressions based on that particular row. In the similar fashion, the maximum function operates as well, but over here, instead of minimum, it will give us the maximum value. Let us quickly create two calculated fields, one to calculate the minimum of the order date, the other to calculate the maximum of the order date. We'll call this one minimum and hit OK. In order to create another field that is maximum of order date, we can right click on it and duplicate the same. Thereafter, we will quickly edit this field and change the function to maximum instead, along with changing the name as well. Let us quickly bring these two fields onto the text shelf. We can see both minimum and maximum of order date out here in the view. In the similar fashion, we can bring up the today and now functions as well. Let us double click in the available space on the marks card and write up the functions respectively. The same is available to us out here in this view as well. In the next video, we will learn about table calculations in Tableau.